Hi, I'm Scott Yeager, Managing Director of Strategic Development at Enron, and I want to help you understand what the Internet is and why it doesn't work so well sometimes. The Internet is an amazing thing that has several advantages: flexibility, ubiquity, and easy access to global sources of information. However, it also has some problems. I'm going to focus on congestion in the Internet and why we believe the Internet is incapable of migrating to a broadband platform that can deliver on its original promise of becoming the new medium for e-business. Internet is short for interconnected networks. It's simply an aggregation of multiple networks owned and managed by different companies. These different networks are physically interconnected inside facilities known as peering points or exchange points. Traffic from one service provider's customers destined for recipients on another provider's network must go through exchange points. The big providers do not charge each other for exchanging this traffic. This creates something known as hot potato routing. Since there is no economic incentive to manage other people's traffic, service providers will move traffic bound for other providers off their own networks as soon as possible. There are a few regional exchange points scattered around the country connecting different service providers, but virtually all of them interconnect to two national exchanges: the Metropolitan Exchange in Washington, D.C., which we call May East, and a similar facility in San Jose, which we call May West. These two exchanges move the most traffic. A lot of this traffic comes from people using the web for one reason or another. A financial analyst in New York, for example, might be researching a company on the West Coast. If we follow the packets or envelopes of data, we can see why there are problems. We're going out over the local loop, which typically is a circuit leased by the company. From there, the packet goes over another circuit to the Internet Service Provider or ISP. If this was a dial-up connection, the packet would go into the ISP's modem banks and then into the router. The router looks up the destination and finds that the address is not on its backbone, so it sends the packet to the closest national exchange, May East. Virtually all the major service providers interconnect here. The amount of data that's exchanged is huge, so there's congestion. To minimize cost, hot potato routing dictates that a service provider should offload traffic bound for another network at the closest point possible, in this case, May East. A router in May East looks up the destination and sees that the address is on a network connected to May West. The packets are routed to a long-haul backbone and sent to San Jose via Chicago. Just like May East, an enormous amount of traffic is exchanged in May West. A router here looks up the address and sends the packet to the backbone provider that has the destination connected to it. From the backbone, the packet goes through another service provider's point of presence, which may or may not have congestion. From the POP, it goes over the phone company's local loop to a competitive local exchange carrier. This carrier provides the final link, known as the last mile, to the recipient destination. If this loop is oversubscribed, congestion will occur. Congestion can also occur if there are too many simultaneous users requesting content from the servers. The content flows back over the same interconnecting series of routers and backbones. At any point in time, one or many points of congestion occur on the return path, causing delay. No one can determine when or where congestion will occur, so it's not possible to guarantee throughput or quality of service. The random nature of this congestion is compounded when millions of users are requesting and receiving information all over the country, all over the world. Since the Internet is non-deterministic, it is not able to handle applications that need guaranteed quality of service. As broadband applications become more common, the problem becomes worse, even if you put more bandwidth in the internet. Just increasing bandwidth in the backbone doesn't fix the problem. Distributing servers to the edge by itself doesn't fix the problem. Routing around the MAE by itself doesn't fix the problem. And just getting a fast connection through the local loop to your ISP doesn't fix it. Enron is engineering an end-to-end quality of service solution that avoids all the congestion points: the local loops, the pooling and exchange points, the servers, and the backbones. By offering tiered quality of service levels, Enron gives content providers and end users a way to purchase the quality of service they need, and we guarantee delivery of that. For those things that don't need guaranteed delivery, content providers and end users will continue to use the non-deterministic internet. We're working with our technology and distribution partners to deliver these solutions to the desktop, enabling the desktop of the future today.